welcome to another episode of the Data Science Mentor Program. And the Data Science Mentor Cohort, what we do is help folks learning data science from scratch using examples and mentorship. My name is Pablo. I am a data science professional. I'm a founder of the Data Science Mentor Program, and I'm the host and convener of the cohort. Right. So what we're doing in today's session is basically we are wrapping one section before we go to another section. We have been doing a bunch of things since we started out the first session, right? And so today we're going to look at grid search. We have done stuff like build simple models, really simple ones, not a deep dive, and we have also gone on to look at the trade-off between bias and variance. And then we went on to look at validation curves and learning curves. Now, today we're going to look at grid search. And as usual, I am going to talk about the intuition and very simple analogies, and then go ahead, right, to share how we'll typically use grid search when building machine learning models. Right, so the first thing I'm going to do is to share an intuitive, a non-technical definition of a grid search. So this is what I'm going to call this non-technical definition. Now, with a non-technical definition of a grid search, I need you to think about grid search in this way. Think of a grid search like you have a treasure hunt. You think of it as a treasure hunt. Now, in a treasure hunt, you have a map. Now, this map is our ML model. That's our ML model. Now, the treasure in our treasure hunt is basically the best settings. The best settings for an optimal ML model. Now, if I say this, the treasure, okay, let's say this, the treasure is the best setting. Let's call this the treasure is the best settings. Now, when we say the best settings, the best representation is the hyperparameters. Right? So the hyperparameters makes your model perform the best, right? Now, the grid search tries or is basically all possible combinations of these settings, right? So here the grid search tries all possible combinations of these settings. That's the hyperparameter. It tries all possible combinations of these settings. Now, how do we get all possible combinations of these settings? So we're going to do that from a list you provide, right? And from that list, we're going to find the best one. That's basically what a grid search is. Now, if this is your first time watching this and you're wondering, okay, what am I talking about? Please check out the 9th, the 8th, the 7th, 6, 5, 4, 3, 2, 1 sessions. That's basically starting from scratch, and you make sense of it. If you start at 10, which is this, you start at this 10 or 10, then you just miss out on the context, right? And so so that means you probably have to watch the recorded session. So if you are signed up for the data science mentor program, you should have access to these resources. Now, it's so this is basically like what it is. If you're cooking, you try different combinations of salt, pepper, different seasonings, and that's basically what you are trying to do. Now, when you're building ML models, there are parameters. They're like knobs. They're knobs on a radio, and you use that. You set it up before training. You want to know a bunch of things about it. Now, doing this is can be pretty tenuous. So one of the best things you do is to create a grid search function, sort of like a function that helps you through this list that you provide, try out a bunch of things for you. Right. So why is a grid search so important? Right. So let me put this. Why are grid searches useful? Why are grid searches useful? Again, I'll just highlight a few reasons why they're useful. One, it ensures no guesswork. So you're not you typically you want to test all combinations, all the knobs you're tuning, your hyperparameter tuning, in order to know how best to solve the problem. Because you're trying to solve a problem, you're trying to predict an outcome, and this outcome is basically the problem case or the discovery or the decision you're trying to make. Another thing you want to do is, you don't want to miss the better setting. So so you don't want to miss a better setting. Again, it's sort of like the guesswork thing, right? So you are not just going to be trying out random values, right? And also one final part is grid search works well with cross-validation. If at this point you're asking me, oh, wait a minute, what's cross-validation? It means you need to go and watch the other videos. Check out your resources. If you don't have access to that, then it means you're not signed up to the data science mentor cohort. So basically drop an information. If you're watching this live, maybe if this session was streamed live, then you could just drop a message, or you drop a comment in the comment section. Let me know if you're interested in signing up. Right. So this works. So again, this works well with cross-validation. So at this point, you should know cross-validation, right? And if you use cross-validation, you're doing that because you want to avoid high variance, that's overfitting. So these are the reasons why. Now the next thing we're going to do is now go straight into the hands-on part. Again, for this part, I'm going to follow what I have been doing, so which is it's basically a very simple illustration. I'll follow what I have done previously. So at this point, it would really be great for you to watch the previous video before now. So what I'm going to do is I have created some data points like X. See that? If I check X is it's not data points basically. I created random data that reflects a feature matrix. So if I check the shape, it's just going to tell me. You can see now feature matrix has a number of samples and number of features, And at this point, if you're again asking yourself, what is a feature matrix? And that means you should go check out the other videos. So we have already done this. We have Y, which is a target, and it's just with a sample. So now what we're going to make, now we want to fit our model to this data point or to the data, and so that we can do some sort of a prediction. But here it's not a prediction, it's an illustration of how grid search works. Right, so the first I'll do, as usual, is to, get my model class, which are part of like the 4 things we will typically do, right? So I'll get my model class, and so here I'm going to say from sklearn dot model selection. I'll import grid search CV. So that's the first thing. So I've gotten that. Now the next thing I want to do is I'm going to create like a parameter. Inside this parameter, it's like a pipeline. I'm going to create like a parameter. And just to illustrate how the grid search works, right? It's like I'm going to use it's like a normal estimator, but this time I'm going to apply it to the data, and then it would try to fit the data based on the list of parameters I give to it. So next, I'll create something. I'll call this param underscore grid, which is like parameters of the grid search. Now in here, I'll create a dictionary. Now we had prior to this, we had used polynomial regression to create degrees for which we could tune the complexity of our models. So I'm going to create this. I'm going to call this polynomial features. Underscore degree. Again, if at this point you're still asking yourself, what's a polynomial degree or polynomial features degree, or what am I talking about in terms of degrees? It means you should go and watch the previous videos. So this, and so with the dictionary, we have a key and there's a value pair. So we go NP dot. Now, the reason I can use NP is because previously I've imported the NumPy model. So I've already done that, right? So I could call NP, right? But if it's your first time watching this, if you're watching a recorded session or watching it on YouTube, remember that you have to import the relevant models. So np.arange. Now with np.arange, I put 21. So that tells you the number of degrees I would want to tune the polynomials I'm trying to tune to get to the favorable, to get something favorable, and I'm testing it now with this. That means I'm going to tune my polynomials to like 21 degrees or 20 degrees, right? So the next I'm going to do is I'm now going to introduce so this one, it's a linear regression underscore fit underscore intersect. So I'm going to introduce this, and these are typically like these are so these are parameters that can use. There's several parameters, and I'm going to share in the WhatsApp, in the Telegram channel, I'm going to share documentation that reflects this, right? So with this, I'm going to put a list, and in the list, I'm going to say true, comma, false. And then I'm going to close this dictionary. Right, so with this, I have my parameter for my grid search. Then I'm going to call this grid. In here, I'm going to now call grid search, which is this model. I'm going to call grid search CV. Now with this grid search CV, it's sort of like I am instantiating the model class. And inside of it, I'm going to now call polynomial regression. Yes, polynomial regression. Again, the reason why this happened is because, and formally, in the other classes we've had, I've had to do some, you can see, this is the history of what we've done. You can see that I called the polynomial features linear regression, and also it makes it pretty easy for me to do some of the things I'm doing. You can see I had created a polynomial regression function that takes in the degree to which I want to tune polynomials, and then that has a keyword arguments, arbitrary number of keyword arguments. So pretty not surprised when you see this. If you're surprised at this point, it means you've not seen the other videos. Again, you're going to go check them out. So here, I'll call the polynomial regression, and I'm going to call param grid. And then remember that part of the advantage of using a grid set is that it works well with cross-validation, right? Again, at this point, you ask, what is cross-validation? Go check out the other videos, and you'll be there. And if you're finding it hard to find these other videos, and if they are not streamed live, not all our sessions are streamed live. If it's not streamed live, then we typically want to sign up to this cohort. Right. So with this, I will now write CV as 7. So I have this set up. So we already have this. Now, we haven't applied, we've set this up and we haven't applied it to any data, right? So next one we're going to do is we're going to fit it to a data. So I'm going to go grid. Okay, hold on. I'm going to go grid. And I'll say grid dot grid.fit, because that's where I have this. I'll say grid.fit. And remember, I showed you both the data. This data has the data. This data is represented to fit the scikit-learn estimator API. So we have talked about data representation in scikit-learn. I think that should be our second session during the machine learning episode. Do check it out. Right. If you are in the data science mentor cohort, you would have access to that. So yeah, so now we're going to pick X and Y. We're going to pick this, right? And we're going to pick this, and we will run this, right? Where do I have that? What do you say? Well, I must have made a mistake here. Let me see. I'm gonna run this, and then I'll come back here and I'll run this. Okay, so let's see what is the error here again. Invalid kernel for estimator. Memory steps and goals. Okay, let's run this. Come over here and run this. Aha, so now again, Okay, so just hold on a bit. I may have made a oh, mm, mm. Hold on. Let me go back again. Again, the let me still write true or false. True, comma, false. Right? I feel like yeah. Run. So let's go back here now and be sure. So polynomial clues for the estimator pipeline. Let's just about the polynomial features. What am I doing? I am making so many mistakes. Okay, let's see. Run this again. I made a bunch of mistakes. And then now that should work. I made a bunch of mistakes, and so now we fit this model. Now, if we now once we do this, we are now going to do something called grid dot. So this guy is called the best params, right? So this is basically saying the best params, and what it's going to do is it's going to give us this empty. It's a new dictionary, and it's just going to initialize a bunch of stuff inside. So for us to get the best parameters. So once I do this, I run this. It tells me the best parameter is false, and the best degree for which we can tune our model is 4. 4 degrees. We tune it. Yeah, 4 for our polynomials, we tune it into 4 degrees. And that's what is going to be. Now, to this end, right, we will now try to see, okay, if this best fits the model, right, we can now go on to plot it. We can now go on to plot it to see what it looks like, right? So we go on here and we now type model, and inside our model, we can now say grid dot best estimator, right? That's what we're going to put in here. Now with the grid dot best estimator, what we are going to do at this point is to visualize it. Remember, we have this has 40 is it 40 samples, right? And we can now look at how this parameters gets to fit in really well. And the best way to do it is to visualize our curve, right? When we visualize our curve is going to show us how well it fits it fits the target features with respect to observed and predicted. Right. So that's typically what it would be when you do your thing. So plt.scatter, and here we say x dot yeah. So basically, that's what we're trying to do: scatter plots which vary in size, right? And then y. Then next, what we're going to do is we'll set a lim, and here we're going to say plt. Our limit is to our axis. Then we have y underscore tests. Right, what we're going to do in this y underscore test part of it, we already have y underscore test. We've already created it before now. Just so that you don't see that we're making this up again. If we have this y underscore test dot shape, it's because it's a part of what we had created earlier on. Not y underscore test, basically. I mean x underscore test is a mistake. X underscore test, which is supposed to be it's a part of what we are. Yes, x underscore test. So with this, we're typically going to predict like new variables, so to speak, right? So here we say y underscore test and say our model, right, dot fit x comma y dot predict yes, and inside we're going to have x underscore test. That's what we're going to do. Then we can say plt dot plots. All the things are going to be plotted on inside one. We're going to say x underscore test dot. It's going to set we're going to set up our visuals for this within an axis, and then we have y underscore test, which at this point it tells you it's a predicted, and we're going to have both predicted and observed variables all in together, right? And then we have plt dot axis, and we have lim, which is our name, and then we have plt dot show. Now, if you look at what we have here, we're having first of all, we have a scatter plot of both our what we've predicted and our predicted values and observed values, and then we're trying to find the line that best fits. Now, previously, sometimes the line that best fits does not fit because of the variability of the features we have. And I'll just again help you guys see where this is. This is it. Sometimes the line that best fits just 1 degree of the first linear regression model may not actually fit because of how variable it is. It may not actually fit. So what you're looking for is using polynomial regression to find a way to make it fit. It's a way that says, okay, how do I, since the line that best fits doesn't typically make it work, then we might just use we basically introduce polynomial features that enable us find really curving. It's just like having a way to curve our line that makes it work, right? So and so that's basically what we are going to use. So it's sort of like it's a polynomial regression model that uses a polynomial feature, and with that we have degrees of polynomials that enable us to tune our parameters, and these degrees are what you see over here. These are the degrees you see over here. So this first one is just the first one we did, which gives us this straight line, and then these others are the polynomials that enable us to tune our parameters. And here, what we did at this place was to, do this, and we had this. But now this isn't what we are about. This is basically telling you what grid search does. With grid search, right, it's like a treasure hunt, right? We have a map, which is our model, and our treasure is the best settings, and they're the hyperparameters. So now the grid tries all possible combination of these settings based on what we provide. Now, why is it useful to have a grid search? It ensures we don't do some guesswork. We don't want to miss a better setting, and it works well with cross validation to avoid overfitting, which is high variant. Right. So with that, we use our tests, data sets, which is what we had created earlier on. If you didn't see how we created this, it means you have to watch the earlier videos. And then we, imported our class, what are our model class. We now created a param underscore grid where we say, look, we're using our polynomial features for the features we're going to use to tune our parameters. And we say, look, we give it 20 degrees. And then we introduce the linear regression fits underscore intercept and say, look, let's look at the two features, which is true or false. Right now, the grid we instantiated the grid search, right? Saying, look, we're using polynomial regression, which will enable us to set a generalized linear regression model. And we're going to use our param underscore grid. And remember, it works really well. So it's going to split our data, into cross-validation and different setups so that we don't have, we don't have a situation where it understands the model, right? So that we don't have a situation where it understands our training data. And then we fit it. And then we figured out what was the best parameters. From there, we got our best estimator since we've gotten our best parameters and went on to visualize how it performed with new features. And this is what it did. It tried its best to fit in. So this is what we do. This is grid search. This is typically what grid search is about. And with grid search, it makes it easy for you to, tune your parameters using an efficient way, efficient means of tuning your parameters. Right. So basically, this is what it is. It's generally the idea of model validation and hyperparameter optimization. And we're looking at really, intuitive ways between the trade-off between bias, which is like underfitting, and variance, which is overfitting. When your model underfits, it does not generalize, it doesn't understand its training. Maybe it could be too complex for it. Or at the same time, if it overfits, that means it understood the training data, it understood the patterns, but it cannot generalize to a new model. It's like trying to predict salaries, just using you're trying to predict salaries and the explanatory variables and the target variables, and you use your model, and we're expecting a very great output, but it doesn't get a pattern, and so it underfits. But if on the other hand, it could understand the pattern, the complexity of the model so well on the training data, but then it does not know how to generalize to new data. So the idea, it is vital to tune your parameters in order to avoid, underfitting or overfitting. And to do that, you have to now find a very, very interesting way to do that. And that's what grid search does. Finally, so this I just mentioned is basically a rundown of what we've been doing. In our next session, we are going to look at feature engineering, which is, this first session, the first 10, we have looked at the fundamental ideas of machine learning, right? However, we're now going to go into some common features of machine learning that makes the machine learning technique, work. And what we're going to do in our 11th session is feature engineering. All right, so that's what it is. So if this session was streamed live, jump on the comment section and let me know what you think. If you are signed up to the Data Science Mentor Program, what it means is you have a chance of watching this, and you can also comment if you're on the live sessions. Or if you're watching the recorded session, feel free to drop a question in the Telegram channel, in our private Telegram channel, and I'll reach out to you for us to further on that conversation. All right, guys, thank you for this session.